Hi students, this is part 3 video, continuation of part 2 heat lesson. So students, previous class I told some activities. In this class we will discuss about some interesting concept. What is that concept? That concept is called specific heat. Generally, heat is a form of energy. It can be transferred from one form to another form. Temperature, the degree of hotness or coldness is called temperature. But in this heat lesson, another wonderful concept that is called specific heat. I will explain specific heat. Before we learn about one interesting activity that is very easy. I will explain. Just see this. For example, take a small beaker. This is called small beaker. It is filled with 250 grams of water. 250 grams of water. Take larger beaker. It is filled with 1 liter of water. This is called larger beaker. Okay? Take a small beaker, 250 grams of water. Take a larger beaker, is filled with 1 liter of water. Now, heat both beakers. Heat both beakers. This is 250 grams. This is 1 liter. This is small beaker. This is larger beaker. Now, heat both beakers. After some time, you will observe. Take 2 thermometers kept into this. This is 1 thermometer. This is 1 thermometer. Observe the 2 readings, 2 thermometer readings. After some time, the heat time required is more in larger beaker or smaller beaker? Yes, larger beaker. Heat time required energy, more energy. It means more time. Ekku time denik padutundi. Yes, larger beaker. Because it has larger quantity, it has smaller quantity. What is this meaning? This is lesser time, this is minimum time, this is maximum time. So, the heating time required is more in larger beaker because its quantity has maximum. The heat time required is heat energy in lesser time. In which beaker? Smaller beaker. Because it has smaller quantity. That's why for change in temperature is constant. Please remember, in this activity, the initial temperature must be equal. The initial temperature is constant. Means delta T. What is delta T? Delta means change. Delta T is constant. When delta T is constant, here heating time required is more. Heating time is more. In which beaker? Larger beaker. Heating time is less. In which beaker? Smaller beaker. Because what is the difference? Quantity. In our physics, quantity is nothing but mass. Do you know mass? Mass of the substance. Mass is nothing but weight. Okay? So, then finally students, Q, heat energy, is directly proportional to mass of the substance. What is Q? Heat energy. What is M? Mass. It means it is nothing but quantity. It is nothing but weight. That is called mass. So, heat energy increases, then quantity increases. So, quantity increases, that heating time increases. So, here, delta T is constant. What is that? Heat energy is directly proportional to mass of the substance. So, this is equation 1. Okay students, this is the equation 1. What is the equation 1? Q is directly proportional to mass. So this is equation 1. Now another. What is another? Now take 1 liter of water, 1 beaker. Now take 1 liter of water in 1 beaker. For every 2 minutes, changes the temperature. We will observe for every 2 minutes changes the temperature. Okay? Take 1 liter of water in a beaker. Now heat that beaker. We will observe every 2 or 3 minutes temperature changes with time. So with time is constant. We will observe that increase the temperature. Temperature increases every 2 or 3 minutes. What do you conclude this topic? Heat energy means Q. Already this beaker heated. Already heated. So every 2 minutes you observe changes the temperature. What is called? Delta T. Here mass means 1 liter. It is constant. What is M? Mass is constant. What is the mass? 1 liter of water. Take 1 liter of water is nothing but mass. It is constant. Now heat this beaker. For every 2 or 3 minutes, you will observe change in temperature. Definitely, this change in temperature increases with time. Time తో పాటుగా ఇక్కడ ఉన్న టెంపరేచర్ ఏమవుతుందండి? పెరుగుతూ ఉంటుంది. సో increase అవుతూ ఉంటుంది. So then finally, Q, heat energy, is directly proportional to delta T. It means change in temperature. Here, M is constant. What is first equation? Q is directly proportional to mass. Here delta T is constant. Okay students, from this is equation 1, this is equation 2. From 1 and 2. From 1 and 2. What is this? Q. What is this? Q. 1Q. What is this? Proportional. This is also proportional. What is this? M. What is this? Delta T. So multiply these two terms. M into delta T. M delta T. So in our physics, we remove this proportionality. In that place, keeping one constant. So is equal to. What is that? Constant into M delta T. Here, in this concept, from these two equations, here constant is called, already I told, specific heat. Specific heat. So, here specific heat is denoted by letter S. So, S is called specific heat. M delta T. So then finally, Q is equal to MS delta T. Here S is called, what is that? Specific heat. So S is called specific heat. Okay students, what is that equation? Q is equal to MS delta T. Here constant is called S. S is called specific heat of the given material. So, what is the equation of specific heat? What is the equation of specific heat from last required equation? From last, what is that equation? Q is equal to MS delta T. What is M? Mass. What is S? Specific heat. What is delta T? Change in temperature. Now, in this equation, we want, what is the substance? Specific heat. So, S is equal to, what is this? Q. What is this? M delta T. So, replace these terms. So, Q by M delta T. So, it is very important formula. What is this formula? specific heat. So S is equal to Q by M delta T. What is the definition of specific heat? What is the definition of specific heat? What is the definition? What is this mass? What is this changing temperature? What is Q? Heat energy. So Q is equal to heat energy. M is equal to mass of the substance. So delta T is equal to change in temperature. So delta T is equal to change in temperature. Q is equal to heat energy. M is equal to mass of the substance. What is the definition of specific heat? Okay, please see the students. The amount of heat means Q required అంటే మనకి కావాలి హీట్ కావాలంటే to raise the temperature delta T అప్పుడు టెంపరేచర్ ని రేస్ చేయాలి of unit mass of a substance. Yes, ఒక యూనిట్ మాస్ ఆఫ్ ఏ సబ్స్టాన్స్ by 1 degree Celsius. Okay, let us start. The amount of heat, what is this? Q. The amount of heat Q required means to raise the temperature. To raise the temperature means delta T of unit mass of a substance. Unit mass of a substance mean M by 1 degree Celsius. So that heat required energy is called specific heat. So students, what are the units of specific heat? What are the units of specific heat? Okay, we will discuss units. What are the units of specific heat? Yes, S is equal to, what is the equation? Q by M delta T. Here units has two types. One is CGS system, another is SI system. Now we will discuss CGS system. What is the formula of specific heat? Q by M delta T. What is Q? Heat. Heat is measured in CGS system calorie means CAL per by, what is in CGS system? What are the units in CGS system for mass? Gram. What are the units of CGS system in delta T? For delta T means temperature, degree Celsius. Okay students, Q calorie, M gram, delta T degree Celsius. Then finally in CGS system this specific heat of heat energy means units calorie per gram degree Celsius. Now we enter into this. What is this? SA system. It is nothing but already I told MKS system. So another one again chapandi. Q heat energy. Heat energy in CGS calorie, but SA system joule. J. But M means in CGS system gram, but here kilogram means kg. In CGS system delta T degree Celsius, but here Kelvin. Kelvin is indicated letter K. So then finally, what are the units of specific heat in CGS system? Calorie per gram degree Celsius. What are the units of specific heat in SA system? Joule per kg Kelvin. What is the conversion of this factor? Okay, let us start. 1 calorie per gram degree Celsius is equal to 4.186 into 10 to the power of 3 joule per kg Kelvin. It is very important. So how to convert in CGS system into SA system? We should apply this number. What is this number? 4.186 into 10 power 3 joule per kg Kelvin. So we conversion 1 calorie per gram degree Celsius is equal to 4.186 into 10 power 3 joule per kg Kelvin. Now students, S is equal to Q by m delta t, please listen. This is numerator, this is denominator. మీ అందరికీ తెలుసు, ఎప్పుడైనా సరే డినామినేటర్లో ఏదైనా ఫ్యాక్టర్ ఉన్నప్పుడు ఇక్కడ ఉండేదానికి ఏమవుతుందండి, ఆపోజిట్ అవుతుందండి. అంటే ఇక్కడ ఏముంది, స్పెసిఫిక్ హీట్. మరి కింద ఏమున్నాయి, m డెల్టా టీ. మనం ఇప్పుడు డెల్టా టీని కన్సిడర్ చేసుకుందాం. ఫర్ ఎగ్జాంపుల్ డెల్టా టీ కింద ఉంది కాబట్టి డెల్టా టీ ఇంక్రీజ్. ఫర్ ఎగ్జాంపుల్ డెల్టా టీ మీన్స్ if temperature increases, then specific heat decreases. For example, change in temperature decreases, then specific heat increases. Are you understand? ఇది increase అయితే ఇది decrease అవుతుంది, ఒకవేళ ఇది increase అయితే ఇది decrease అవుతుంది. What we conclude? Specific heat, yes, change in temperature delta T is must inversely proportional. Okay, specific heat is inversely proportional. Specific heat is opposite to change in temperature. Now students, for every material specific heat is opposite to change in temperature. For example, if the temperature is high, specific heat is low. If the temperature is low, specific heat is high. It is the idea of
heat of a substance is the amount of heat energy absorbed or lost by that substance to change its temperature. Now, the hot water bag consists of hot water. As compared to other liquids like milk and acetone, the specific heat of water is much higher. This means that as compared to others, water needs to absorb a large amount of heat to become hotter. Now, did you know that water will take a long time to cool down as compared to milk and acetone? Thus, water will take a longer time to become cool. Hence, it proves to be very useful in hot water bags because the warmth can be utilized for a longer time.
It is the degree of reluctance of this substance. So, specific heat is always inversely proportional to change in temperature. So, it is the important concept. Now, let us start. What is the formula of specific heat? S is equal to Q by m delta T. Here, in our public examination, one question is very, very important. That is one question. That is, why is specific heat different for different substances? అన్ని చోట్ల అన్ని సబ్స్టెన్స్కి ఒకేలా ఉండదండి, మారిపోద్ది. ఎందుకు మారిపోద్ది అనేది ఈ క్వశ్చన్. It is totally depends internal energy. What is internal energy? Already I told one definition. The rate of rise in temperature. The rate of rise, rate means time. Previous class, it means part 2 class. I will explain. No, I told you. Rate means time. The rate of rise in temperature is depends on nature of the substance. The rate of rise in temperature is depends on nature of the substance. Automatically, specific heat also nature of the is depends on nature of the substance. So specific heat is depends on nature of the substance because the rate of rise in temperature is depends on nature of the substance. So that's why specific heat is high, then temperature is low. Then temperature is high, then specific heat is high, low. It means opposite to specific heat and change in temperature. Okay, why specific heat different for different substances? For example, if a body means temperature is directly proportional to average kinetic energy. Previous లో మనం చెప్పుకున్నాం ఫుడ్ కలర్ అనేది ఎలా మూవ్ అవుతుంది అనేది కైనెటిక్ ఎనర్జీ గురించి. సో what is that? Temperature is directly proportional to average kinetic energy of the molecules. Yes, temperature is directly proportional to average kinetic energy. So in this system, molecules have different forms of energy. One is linear kinetic energy, rotational kinetic energy, vibrational kinetic energy, and potential energy. What is that? Linear kinetic energy, rotational kinetic energy, vibrational kinetic energy, and potential energy. These all energies, including the total energy, is called internal energy. Okay, students, what is internal energy? If molecule have, a substance have different forms of energy, that is linear kinetic energy, rotational kinetic energy, vibrational kinetic energy, potential energy between them, that molecules. So the total energy is called internal energy. It is very, very important. Internal energy. So students, we supply heat energy to the system. Means a substance ki మనం heat energy ni supply చేస్తే the amount of heat given to it will be shared by molecules in the form of various forms of energy. అంటే మనం ఏదైనా heat ని సప్లై చేస్తే అది తీసుకుని అది ఏం చేస్తుంది, డిఫరెంట్ ఫార్మ్స్ ఆఫ్ ఎనర్జీకి షేర్ చేస్తుంది. ఇట్ విల్ బి షేర్డ్ బై అమౌంట్ డిఫరెంట్ ఫార్మ్స్ ఆఫ్ ఎనర్జీ. దిస్ షేరింగ్ this share of energy will vary means changes. So in this case, this sharing of energy will vary from substance to substance. This sharing of heat energy will vary from substance to substance. That's why that temperature means specific heat is different for different substances. What is that? If the temperature is high, then specific heat is low. So maximum heat energy absorbed, so increase its linear kinetic energy. That's why it will sharing of energy is depends on temperature. So that's why specific heat is different for different substances. Okay, students. So linear kinetic energy, rotational kinetic energy, vibrational energy, potential energy between that molecules, this total energy is called internal energy. This internal energy, it will be shared in the system, different forms of energy. Okay, this sharing of energy will vary from substance to substance. That's why specific heat is also different for different substances. We know that the specific heat of a substance, how much heat is required to reach the unit mass of a substance through unit degree. What is using this relation? Q is equal to ms delta T. By using this equation, or S is equal to Q by m delta T, by using this relation, we will find the specific heat of a substance. Okay, let us start, students. Let us start. What is internal energy? The molecules have different forms of energy: linear energy, rotational energy, vibrational energy, potential energy between that molecule. This total energy is called internal energy. It is very important. It is very difficult. So this internal energy, it will be shared in sharing of by molecules different forms of energy. This sharing of heat energy will vary from substance to substance. Specific heat also different for different substances. So it is very, very important. మీ అందరికీ నేను హోంవర్క్ లో ఈ పార్ట్ 3 లో ఈ క్వశ్చన్ ఇస్తున్నాను. సో ఇట్ ఈస్ వెరీ, వెరీ ఇంపార్టెంట్. ప్రీవియస్ అంతకుముందు మన పబ్లిక్లో చూసుకుంటే ఈ క్వశ్చన్ 2 మార్క్స్కి ఇచ్చాడండి. ఇట్ ఈస్ వెరీ, వెరీ, వెరీ ఇంపార్టెంట్. సో లెట్ us this concept. Students, previous units relation, 1 calorie per gram is equal to 4.186 into 10 cube joule per kg Kelvin. Why specific heat is different for different substances? What is internal energy? What is the heat energy? Q is equal to ms delta T. Okay, ready? So in this case, now we will discuss about what are the applications of specific heat. So in our daily life, so many materials used in our kitchen, and in our daily life, oceans means samudram. In our daily life, so many fruit. What is the mango, orange, watermelon, something like that. Okay, in our daily life, in this case, what are the applications of specific heat? So one is very important, that is oceans. So students, water masses like oceans, they absorb large amount of sunlight to maintain relatively constant temperature. Why? It is because of their higher specific heat capacity. That's why these oceans act as store heat houses. So this transfer of stored energy to the areas surrounding the poles. A poles దగ్గర ఉన్నటువంటి సరౌండింగ్ ఏరియాకి పోల్స్ కి ఏం చేస్తుంది? ఈ స్టోర్డ్ ఎనర్జీని ట్రాన్స్ఫర్ చేస్తుంది టు మెయింటైన్ మోడరేట్ టెంపరేచర్ బిట్వీన్ ఈక్వేటర్ అండ్ poles. It is one of the example of means application of specific heat. What is that? Water masses like oceans, they absorb so much large amount of sunlight to maintain constant temperature. That's why the higher specific heat the ocean stored heat houses act as. This stored energy to the area surrounding the poles. అదేం చేస్తుంది? టు మెయింటైన్ మోడరేట్ టెంపరేచర్ బిట్వీన్ ఈక్వేటర్ అండ్ పోల్స్. ఓకే, నెక్స్ట్ వన్, రిఫ్రిజిరేటర్. డూ యూ నో రిఫ్రిజిరేటర్? ఇన్ అవర్ హోమ్ డూ యూ హ్యావ్ రిఫ్రిజిరేటర్? ఎస్, నౌవేడేస్ అందరికీ రిఫ్రిజిరేటర్లు ఉన్నాయి. సో అందులో మనం mango, orange, different apples and watermelon also. Deep freeze. Keep it in deep fridge. అందులో పెట్టండి. After some time, remove all fruits from the deep freeze. In which fruit retains its coolness? It is very longer time. It is very cool. For longer time. In which fruit? Yes, obviously your answer is correct. That is watermelon. Because the watermelon has large percentage of water. In this fruit, sufficiently large amount of heat required sufficiently to raise the temperature by 1 degree Celsius. Because water has large specific heat. In this fruit, large percentage of water. That's why it's very coolness. It retains its coolness in this fruit than compared to other fruits. Okay. So then finally, water has more specific heat. Okay, students. So this is fruit. What is that fruit? Watermelon. It has a larger percentage of water. And next one, it is very easy. Samosa. This samosa, సాధారణంగా మనందరం సినిమాకి వెళ్ళినప్పుడు ఇంటర్వెల్లో సమోసా తింటూ ఉంటాం. ఎక్కడైనా సరే మన ఇంట్లో కూడా చేసుకుంటూ ఉంటారు. సో పైకి అది ఎలా కనిపిస్తుంది? కూల్, But inside the samosa, it means curry. Inside samosa, inside that curry is very hot because ingredients, the higher specific heat of ingredients in that samosa. What is the ingredients? Curry. So students, samosa appear to be very cool from outside, but it is very hot inside because the inside the ingredients higher specific heat capacity. Okay, it is the another example. And next one, in our kitchen, manam kitchen lo utensils, పాత్రలు వెజల్స్ ఉపయోగిస్తూ ఉంటాం. కాపర్ అని అవని ఇవని. ఎస్, ఎందుకు ఉపయోగిస్తాం? వాటికి స్పెసిఫిక్ హీట్ చాలా తక్కువ అండి. లెట్స్ స్టార్ట్. యూటెన్సిల్ యూజ్డ్ ఫర్ మేకింగ్ టీ. ఎస్, టీ, కాఫీ. డూ యు నో? ఎస్. ఆర్ కుకింగ్ వెజిటేబుల్స్. ఎస్. ఆర్ రైస్. ఎస్. ఆర్ మేడ్ ఆఫ్ మెటీరియల్స్. యూటెన్సిల్ మెటీరియల్స్ ఆఫ్ లో స్పెసిఫిక్ హీట్. ఆ తయారు చేసే మెటీరియల్స్ ఏవైతే ఉన్నాయో వాటి లో స్పెసిఫిక్ హీట్తో తయారు చేస్తారు. అందుకనే స్పెసిఫిక్ హీట్ తక్కువ కాబట్టి టెంపరేచర్ చెప్పండి. ఆల్రెడీ ఐ టోల్డ్. ఎస్, స్పెసిఫిక్ హీట్ ఈస్ లో, దెన్ టెంపరేచర్ ఈస్ హై. యా, దట్స్ వై దట్ యుటెన్సిల్ యూజ్డ్ ఫర్ టీ, కాఫీ, కుకింగ్, రైస్, వాట్ ఎల్స్ మే బి, దిస్ మెటీరియల్స్ used because it has low specific heat. So students, please listen carefully and watch carefully this video. It is very very important in our public examinations. What is the important? What is the need your subject? What is the definitions, units, paragraph questions and essay questions, 1 mark questions, half mark questions. It is very 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 important. So students, what are the application of specific heat? What is the definition of specific heat? What are the units of specific heat? What is the activity of specific heat? Temperature is directly proportional to average kinetic energy. The rate of rise in temperature depends on nature of the substance. Why specific heat is different for different substances? Okay students, this is very very important in this class. Okay, see students, we shall meet next online class, that means part 4. Stay home, stay safe. Okay, thank you. This is U.Manikanta, St.Mary's High School, Palakol. Thank you.